So let's continue with our revision trial paper SBP Physics Paper 1 2021. Okay, so two forces P and Q act upon an object on the plane. The resultant force F is P minus Q. The two forces P and Q are acting. So we know that resultant force F net, the formula for it is F1 plus F2. But you need to take into consideration of whether this is positive sign or negative sign. So we assume that towards the right is positive and towards the left is negative. So if I let this become P and this become Q, so you will get P minus Q. So it is in opposite direction. If it is in the same direction, you just P plus Q, because both are moving towards the same direction, both are positive sign. Okay, at an angle of 90 degrees to each other, you will need to use the triangle formula, P square plus Q square, and square root it. You'll be able to find the magnitude of the resultant force at an angle of 120 to each other. So you need to resolve if the force, for example, P, this is P and then this is Q. Okay, so here is 120 degrees. So you will have to resolve the P into horizontal component and vertical components. So this is a horizontal component, this is vertical component, and you minus the horizontal component by Q, and then you get something like this, and then use back the formula here, the triangle formula, to find the magnitude. Okay, so I hope this is clear. So the answer for 21 is boy. Okay, 22. Diagram 15 shows Jonathan pushes a snow sled, which shows the correct direction of the horizontal component of force F1 and vertical component of force Fy. Fx is horizontal component and Fy is the vertical component. So this is your force. You want to resolve it, it will become like this. So this is your horizontal component Fx, and this is your vertical component facing downward. So the answer is donkey. Okay, Fx, Fy. Okay, next, 23. Diagram 16 shows two strings with the angle 15 used to hang a picture that weighs 10N on the wall. Okay, 15, 15, tension. What is the tension of each string? So remember, if one string and bends at the center here, they will no matter bend at whether this at here, or at here, as long as it is the same string, the tension experienced by it will be the same. However, for this question, they already mentioned it is two string, so the string is separate, but it's already mentioned the string have same tension because it have same angle. Okay, so the tension should be the same. And so the weight of the picture is 10N. So 10N. So because this picture is in equilibrium, the upward force equal to downward force. Okay, so the upward force should also be 10N since the downward force is 10N. Okay, so the tension should also be pointing upward. And so first you need to resolve the tension into the vertical components and horizontal components. Okay, so horizontal component and vertical component. So when you resolve it, you resolve these two tension. Okay, this one is for the tension here, and this one is for the tension right side. So because you can observe that the tension is the same for both sides and the angle is same for the both sides, you can just cancel out both the horizontal component, because you can observe that they cancel each other out. Okay, so you just need to take into consideration of the upward force or vertical components. So how we resolve the tension? Remember tension, okay, T, okay, we just use sine theta equals to this is the opposite side and this is the hypotenuse. So your hypotenuse is T and your opposite should be vertical components and your theta should be 50 degrees. So you just move the T here, will be T sine 15 equals to your vertical components. Okay, so you resolve this T and the right hand side T. So T sine 50 plus T sine 15 equals to 10N, because this is the total upward force. So you have 2T sine 15 equals to 10N. So you can find out the T. It should be 10 divided by 2 divided by sine 15. You will get 19.3. So the answer is cat C. Okay, so if you want to find the horizontal components, you just use cos theta equals to adjacent divided by hypotenuse. Okay, so you want to find the adjacent, your hypotenuse refer to T, right? The hypotenuse here is T, so theta is 15, so you will have 15, so you will have T cos 15 equals to your horizontal component. So this is how you find the horizontal component and vertical components. Okay, so here's a shortcut for you. You just need to remember that whenever you want to find the vertical components, you will sorry, not the vertical component. Whenever you want to find the components which is nearer to your angle, you will use cos. You will become what? Your unknown value T, for example here T, cos your angle equals to your horizontal component. Whenever your no matter it is horizontal component or vertical component, it should be nearer to your angle. You want to find the components near to the angle, you will use T cos, you will use the unknown cos and then the angle to find the components near your angle. If you want to find the angle, okay, near further from your angle, you always use sine. Okay, sine. So just remember, near your angle, you use cos. Further from your angle, you use sine. Sine is further. Okay, you can see S. Wow, so long. So further is sine. Nearer is cos. Okay. 26. Diagram 19 shows a U-tube that contains mercury. Okay, so mercury, just a revision, this apparatus is called mercury manometer. Okay, so because the tube is open at here, this is an open tube, so the tube is exposed to the surrounding and therefore you are experiencing atmospheric pressure. So your atmosphere will exert pressure towards the surface at here, and your gas, a particular gas is trapped at the tube, at the end tube here, and the gas will exert pressure towards the end. So just take note that M and N, because they are having the same height, as long as they are having the same height, they will experience the same pressure, right? So the gas, you can observe, they push more the mercury than the atmospheric pressure. So it exerts more pressure, so the mercury here is more upward. So you can say that here is PG, where G is pressure of gas, and here will be pressure of atmospheric pressure plus pressure of mercury. Okay, because as I mentioned just now, H and H, because they are same height, the pressure is same. So at here, just for this region, the pressure will be equals, which means P atmospheric pressure plus mercury pressure will equals to the gas pressure. Okay, so the pressure at M is higher than pressure at N. This is not true because, as I mentioned just now, they should be equal. They should be equal pressure. Okay, the atmospheric pressure is lower than the gas pressure. Atmospheric pressure is lower than the gas pressure. This is true because, as I mentioned, the gas push more than the atmospheric pressure. Or I can prove it to you by using this formula, which means PATM equals to pressure of gas minus pressure of mercury. Okay, so because here is minus, so because this is minus, so your atmospheric pressure should be lower. This is true. The value of D will decrease when the gas pressure increase. So when your gas pressure increase, it will push more the mercury downward, and therefore the D should be increasing because the gas push more downward. The pressure of gas push more downward. Okay, and the density of mercury at M is higher than the density of mercury at N. This is not true because they are the same liquid. That is mercury. So same liquid should have same mercury. So this should be equal. Okay. Okay. So 27, diagram 20 shows a hydraulic jack is used to lift a car. So when you saw this word hydraulic jack, you really know that the principle involved should be Pascal principle. So what is the physics principle involved in the hydraulic jack? So the answer should be Pascal principle. So this is how hydraulic jack works. Okay, so this is your hydraulic jack. This is your handle. Okay, this is your load. So your car is located at here. Okay, this is your tire. Okay, so here should have a piston, and here is another piston. So inside of it is fluid. Okay, fluid. So when you apply force to it, it will exert a pressure on the fluid, and the pressure will be transmitted uniformly throughout the fluid, and therefore your car race. Okay, so what Pascal principle state is that when a pressure is applied to an enclosed fluid, always not to forget to write the word enclosed. So when a pressure is applied to an enclosed fluid, the pressure will be transmitted uniformly throughout the fluid. So the key word here is enclosed fluid and transmitted uniformly. If you just write transmitted, marks will not be given. So remember to write the word enclosed fluid. When the pressure is applied to an enclosed fluid, the pressure will be transmitted uniformly throughout the fluid. Okay, so next, Bernoulli's principle. So what Bernoulli's principle state is that when speed increase, pressure will decrease. Okay, so for example, when the air is moving, then the pressure will be decreasing, and the pressure will be smaller as compared to the pressure of air which is stationary. So Archimedes' principle states that the buoyant force experienced by an object is equal to the weight of fluid displaced by an object. No matter whether the object is partially submerged or completely submerged. And principle of conservation of energy states that uh, total total energy before collision equals to total energy after collision. Okay, total energy before collision equals to total energy after collision. So these three principles have nothing to do with our diagram. So the answer you have is A. So diagram 21 shows a boat of mass 550 kg floating on the sea. Density of seawater is 1080 kg per cubic meter. What is the volume of seawater displaced by the boat? So according to Pascal principle, weight of fluids displaced by an object equals to the buoyant force. Since this is floating, okay, so downward force should equal to upward force. So the upward force is a downward force is the weight, so should be the mass multiplied by gravitational acceleration. So what you get is 550 multiplied by 9.81, you get 5395.5. Okay, so because downward force equals to upward force, so here should also be the upward force should also be equals to 5395.5, and that is our buoyancy. So the formula for the buoyancy is B, which is buoyant force, equals to rho Vg, where rho represents your density of the fluid, which is the seawater in this case, and volume is the volume of water displaced, and G is your gravitational acceleration. So you just substitute in all the value. 5395.5 equals to the density of fluid 1080, and the volume, which is an unknown you need to find, and the G is gravitational acceleration, which is 9.81. So the V here you will get is 1080 multiplied 9.81, 5395.5 divided by 8, you will get 0.509259. So remember, the volume you get is in meter cube. So we know that 1 meter equals to 100 cm. So you just multiply by 1, but because in this case this is in cubic meter, so you have to multiply 100 by 3 times, so you will get one scientific notation. You will get 10 power 6. Okay, so your if you convert it, so you multiply by 10 power 6, you will get 5092592.5. This is 2. So the answer is boy. Okay, because power 5, you will 1, 2, 3, 4, 5. Okay, so this is the answer. The answer is boy. Okay, so diagram 23 shows the arrangements of the apparatus to study the effect of an electric field on the candle flame. So what happens to the candle flame after EHT power supply is turned on? So just further information for you, EHT represents extra high tension, okay? Or usually we call it as high supply voltage, okay? Okay, so what happened to the candle flame after the EHT power supply is turned on? So this is positive, so this should be a positive plate, and this is negative, so this should be a negative plate. So when your when your flame is ignite, it will have positive charge and negative charge, okay? So your flame will become flattened and spread. So it will spread in both directions. As I mentioned just now, your flame, when it is ignite, it will have positive and negative charge. So your positive charge will be attract to your negative plate, and your positive charge, your negative charge will attract to positive plate. Okay, this is positive plate, and this is your negative plate. Okay, so because your positive ions is much heavier, so it will occupy a larger portion in your flame, and negative charge, negative ions, because it is more lighter, so it will occupy smaller portion of your flame. Okay, so when you open the power supply, you will observe that your flame will spread in both directions, and towards the negative plate will have larger portion. So what happens to the candle flame after the extra high tension power supply is turned on? The candle flame will spread out between the plate X and plate Y. Yes, this is true. Okay, as I mentioned just now, it will spread in both directions. The spread of flames towards plate X is greater than plate Y. Plate X, plate Y, yes, because this is negative charge, and your positive ions is attract towards it, and your positive ions is larger. So your positive ions is heavier, so it will occupy a larger portion. So this is also true. The spread of flames towards plate Y is greater than plate X. No, because this is your negative ions. It is lighter, so it will occupy a smaller portion. The brightness of the flame increases. No, it will remain unchanged. So the answer you have is A, 1 and 2. Okay.